We have start. Nous avons le départ actuel. On a le départ actuel.
A lot of companies in the cycling industry have built their brands around certain ideas. Campagnolo has come to signify the best of Italy's passion for cycling. Cervelo has created a perception of cutting-edge design on exclusively high-end bikes. Now Zipp Speed Weaponry has done this as well, or better, than any other brand. They are synonymous with aerodynamics. No other company is as focused on saving watts through aerodynamics. So much so that Zipp has made huge inroads in mass start cycling with super deep wheels like the 808. This made the arrival of the new 303 pretty shocking. Yes, it's light, stiff, and of course, aero. But the 303 is also robust enough to excel on the harsh cobbles of northern France, taking the Cervelo test team to a third place at Roubaix without a single failure. How can aero carbon wheels weighing 1,183 grams possibly withstand that kind of punishment? In a word, testing. We got a behind-the-scenes look at the Zipp Test Lab in Speedway, Indiana, and why it may just be as important as the wind tunnel to this company. Located adjacent to the factory floor, the Zipp Test Lab possesses custom-made, one-of-a-kind test rigs for just about every aspect of every component they make. Development of the 303 for the cobbles relied on one machine in particular, the bump drum. Able to simulate speeds of 50 kilometers per hour, the Zipp engineers can attach different scale bumps to simulate different riding conditions. For the cobbles, they manufacture giant bumps to simulate the worst pave in Europe. With the ability to run the rig at angles of up to 10 degrees, they can also simulate a big attack on the cobbles or a prolonged corner. Zipp also possesses a very straightforward impact rig, which they use to simulate extremely big impacts. To test the rim's braking capabilities, a custom-built rig spins a huge flywheel up to speed, then uses a standard road brake and wheel to stop the flywheel. With multiple heat sensors running, it's simply a matter of engineering the surface for greater performance and reliability. But wheels aren't the only thing Zipp makes or tests. Their other products are tested on a universal test rig and a purpose-built machine for their Vuma Quad and Vuma Chrono cranks. Able to put massive loads on cranks hundreds of thousands of times, it was designed not only to test to the strict European standards, but to allow Zipp engineers to test the cranks in many other configurations. The result has been crank arms that are exceptionally stiff and exceed the toughest standards on the market by over 400%. This is, of course, just a glimpse into the extensive testing Zipp does at the lab. The specifics of what they do is obviously very closely guarded information. But during our trip, two facts continually came up. Two facts that seem to play a huge part in Zipp's product development and give them an edge on much of the competition. One was the fact that the test lab is under the same roof as the factory itself. The other is the idea of failure, namely testing every component to failure. We sat down with test engineer John Ferncombe and asked him about these two facts and what specifically they add to Zipp's products.
So one of the key benefits is testing is on-site, manufacturing is on-site. As we're looking to maybe take a little bit of weight out of a crank set, we can make those cranks. Takes basically a half a day to get those cranks ready, and then with the remaining portion of the day I can put them through some strength and stiffness tests, and we can decide if that's a laminate that's going to be suitable for our product, and then we can invest the time to put it on our fatigue stand. That's one of the key advantages of us having everything in-house, manufacturing and testing. We can iterate much more quickly than if we had to communicate with someone in Asia and then hope that they're carrying out the testing exactly as we specify. But the key thing with failure is that's the whole point of why we have that equipment. I mean, we can run stuff and perform a test and then say, okay, it didn't break. But that doesn't really tell us anything. We need to learn. So as we come into contact with new materials, change processes, things like that, we need to make sure that anything that we change that we think we're moving ahead, we need to have a concrete way of saying, yeah, we definitely made this better. It's not really enough to take it to a point where we say, okay, this is well beyond somebody jumping off of a 2-foot curb. That's great, and that's really comforting to know. But again, we're not learning anything. So that's what it really comes down to. Everything we do back there, we do so we can learn.
Perhaps the cobblestones of northern France express these ideas most articulately. The performance of the 303, a wheel whose development took a path directly through the Zipp test lab, is a testament to this philosophy. By working closely with the design engineers during the entire process and testing each design to failure, no matter how long it takes, Zipp could guarantee the Cervelo test team a set of wheels that would be just as robust as the aluminum box section rims traditionally ridden on the cobbles, but more importantly, lighter, stiffer, more compliant, and of course, more aerodynamic. After our trip to Speedway, Indiana, we truly understood the Zipp Test Lab is not simply ensuring their products meet current standards, but actually ensuring their products will stand up to the rigors of the toughest races in the world when ridden by some of the best athletes in the world. And it doesn't matter how far beyond industry standards Zipp may need to go to get there. It was then that we realized the test lab is truly as important as the wind tunnel to this company that makes its living being aero. I'm Ben Edwards. Thanks for watching TESTRIDER.com.